Hi everyone, today I want to show you the modeling process of a Stormtrooper helmet. Let's start to create two image planes that will be used as reference during the modeling. I'm going to click on Image Plane tool to create the plane. Then I will assign the image. We can change the plane dimension and the transparency with the parameters in the guide bar. I'm going to actually just copy and paste the plane. I rotate the copy until it will be perpendicular to the first plane. By the Move tool, I translate the new image plane and make it coincident along the right edge of the first plane. The snap must be active during this operation. I load the side image and I'll align it by the two options in the panel. I can also assign two images on a single plane, so I'll assign the front and the back image on the front plane. I'm going to move the barycenter of the two planes and make it coincident with the z-axis. I will use the polyquad as first geometry to model the helmet. This primitive is a good compromise for this use case. There are a few edges and faces that make pretty straightforward the modeling. I'm going to change the material properties of the polyquad. Let's give this another color and a different transparency. With this trick, we obtain a good contrast with the background, we will have a perception of the geometry's volume, and we can see the difference image clearly. PolyNurbs combine the simplicity of the polygonal modeling with the precision of the NURBS. There are three levels of editing which make them attractive and very useful. The vertices editing is the first one. We will move, scale, rotate the vertices with the manipulator and slide them along the edges. We can also activate the symmetric option inside the PolyNurbs to speed up the modeling process. I will add some new loops to refine the geometries where is needed. We need some loops also in the ears area, on the mouth and on the nose. I'm going to do some other adjustment to refine the model, and I will show you a trick to create a planar surface. The first step is the creation of a rectangular perimeter. To do this, I select and move some vertices. Okay. In the second step, I'll select all the vertices inside the rectangular perimeter, and with the Move tool, I'll scale them along a single direction with a value close to 0. Now we have a planar surface with a discrete tolerance of approximation. Okay. Finally, with the circle maker, we will transform the rectangular perimeter in circular and define the diameter dimension. The geometries requires another adjustment, so I will rotate and move the vertices to find a better correspondence with the images. I didn't explain how we can align the scene with the image. You can do this by the navigation cube. For instance, click on the front face on the cube, and automatically Inspire Studio orient the scene as an orthogonal front view. Okay, now we can extrude the PolyNurbs faces to complete the helmet. I'm going to drag the selected faces with the mouse. This operation is easy and fast. The forward circular edge must be sharpened, so I'm going to change the parameter on the panel. Now it seems similar to the reference image. You can see how, in real time, we can create new geometries. I used the 3 levels of editing of the PolyNurbs: vertices, edges, and faces. All these geometries can be modified by the manipulator tool. You can move, scale, and rotate. You can also slide some vertices along an edge. To do this, you will hover around one of the selected vertices, and then you will drag one of the arrows. This function makes possible some changes that could be very difficult to do in other way. Okay, now the shape is quite good, and I will pass to another phase. I'm going to use the curve on surface. This tool is very useful in the cases where the projection of the planar curve does not fix the issue. In this case, we will need 3D curves that lie on surface, and we will need to orbit the scene from the front to the right side and follow the reference images. Curve on surface is the perfect tool to fix this case. I'll place the vertices according to the images, and automatically the curve will be generated on the surface. On the curve vertices, there are the handles to manage the curve tension and the level of freedom. In the panel, you will find 3 options: Free 3D, Custom UV, and Auto. The curves editing is simple, and I recommended you play with these parameters and discover the potentiality of this tool. We need some curves, so I'm going to repeat the sequence done to create the first one. The curves will be used to create a subtraction solid and make visible the black space between the helmet components. As you can see, in some areas there is no correspondence between the two reference images, so I'm forced to find the best compromise. I can also add or remove vertices to complete the curves. It's time to create the eyes opening. To do this, I'm going to create a sketch that will be used to trim the helmet. I prefer the solid objects and the Boolean operation compared to the intersection surfaces. In my opinion, they are more stable during the editing. So, I'm going to create a sketch to define the thickness of the solids that will be subtracted from the helmet. The sweep is the right tool to create the solids that I need. So, I'm going to assign as profile the last sketch and use the curves on surface as path. The sweep is a versatile tool and there are a lot of useful options to orient the profiles. You can also assign more than one profile on a path, and we will see this case during the creation of the mouse slate. I'm going to select the two profiles and the path, then I'm going to activate the auto alignment in the guide bar to align the profiles on the path. I will use the rotation option to orient in real time the profiles. In some other CAD software you cannot see the changes in real time and you are forced to switch inside and outside the tool to make effective the changes. We will also need the caps to make a solid the sweep, so I'm going to activate this function in the guide bar. The helmet is a symmetric object. Also, the subtraction solid must be symmetric and should be tangent along the intersection plane. So, I will show you a trick to prevent any discontinuity. This case can be fixed in many ways, but I prefer this workflow. I'm going to create a surface offset with the global value equal to 0, and I'll active the custom option in the guide bar. I'm going to edit the offset of a single face and extend the sweeps over the symmetry plane. Now I'll need something to trim any excess part, so I'm going to create a sketch and trim the sweeps. To complete the operation, I will do the symmetry of the solid and subtract it from the helmet. I remove the transparency to see better the geometries. So I can proceed to create the helmet thickness. Okay, the result seems quite good. So I will make visible the source PolyNurbs, then I'm going to create a duplicate and change the color to distinguish the copy from the source geometries. I'm going to create an offset of 5 mm, so I will select all the faces and dragging a face graphic handle. This is not a normal offset, but with this trick you can create thickness easily from a complex PolyNurbs. Okay, I'm going to subtract the new solid from the helmet and complete the ace area by a trim operation. As you can see, the model becomes more realistic. I round all the edges to have a better result during the rendering phase. So I forgot to create a square hole, so I'm going to extract the faces necessary to create the geometries. By the isolate mode toggle, I clean the scene and make visible only the geometries that I need. I'm going to extend all the boundaries of two surfaces. The first one, all the boundaries, and the second. Extend. Okay. By the Loft tool, I will create two surfaces that generate a closed volume. The Make Manifold is a perfect tool to create solid from a surface intersection. So I'm going to select all the surfaces and the solid is done. Okay. I will create a symmetry and then I will subtract the solids from the helmet and refine all the edges with some rounds. The round creation is easy and works fine also with complex PolyNurbs. We will need the source PolyNurbs of the helmet and one of the subtraction solid used during the modeling. So I can make them visible by the word browser and the construction history. Those geometries are necessary to create the missing covers on the bottom part of the helmet and over the ACE area. In the first case, I'll need a planar symmetry, and in the second, I'm going to create an extrusion from some sketch geometries. By a Boolean intersection between these three solids, the covers will be done. Refinement. I will need a refinement in the AS area, so I will use the surface offset with the custom face to correct the geometries. Okay, let us to model the filters. I'm not an expert, so really I don't know the real name of this part of the helmet. Anyway, we will need a plane coincident with the forward surface of the filter region. So I'm going to show you a trick to create these geometries. I'll use the blend curve to create a segment with 2 points on the surface. I'll place the first and the second point, and I'll change the continuity from default to positional. By another blend curve, I will have the basic elements to create the planar surface. I'm going to create an extrusion with the first blend curve and use the second as a reference direction. This approximates a plane that lies on the surface. I'm going to create a sketch and use the import entities as reference geometries. So I'm going to create a 3-point circle to approximate the shape. I will also need the center line that could be very useful as reference element. So I'm going to extrude the sketch. Okay, but this seems not the best way to do the filters. Um, I can create a different sketch that makes me able to manage better the geometries and speed up the modeling. I'll use the planar surface on the center line as a reference to create the sketch, and with the import entities I will constrain the sketch geometries. Okay, final point. And now I'm going to select the profiles and the reference axis to create a rotational surface and complete the first step to create the filters. I can maintain the sketch geometries without constraint, but I prefer always have the control of the sketch element. If you change something in your model, you don't know which impact this changing will have on a sketch, not constraints. We will need the final element to complete the filter, so I'm going to create another sketch on plane perpendicular to the center surface, and I'll revolve the geometries around the axis to create a ring. Now I'm going to select revolve and select the axis. Okay. So now I need another surface perpendicular to this one. Okay, and now I'm going to create another sketch. And with this sketch, I will trim the excess part of the solid, the ring solid, okay? Okay. I'll put some dimension to control the sketch, and now I'm going to trim. It seems not correct, so I can change the dimension. We will need two filters, so I will use the planar symmetry to add the other one. Okay, so our model is an hybrid solution between the real object and the model for rendering. So some things are not necessary, and we can speed up the modeling. But I prefer this way. We will also need an opening at the bottom of the helmet to put the head. This operation is not necessary, but I will do it anyway. I'm going to create a curve and its symmetry, then I will extrude them to create a solid. Finally, I'm going to subtract the extrusion from the helmet and put the rounds on the edges. The model is ready for the rendering, but before assigning the materials, I will need to fill the void inside the helmet with a dark solid. I will need the solid subtracted to create the helmet thickness, so I will search it in the construction tree and I will make it visible and change the transparency. I'm going to open the material library to define the material properties and I assign the material to the helmet components. Okay, the metal chrome on the filter. Okay. And glossy paint to the helmet and the dark paint to the other elements. I prepared an hemisphere as background made in titanium that, in my opinion, gives a good contrast with the helmet. Now, the model is ready to the render, so I'm going to click on Render Image and Inspire Studio will open the darkroom and start the rendering.